Hello and welcome back to another video with It's Dr. Dan, and what we're going to be looking at today is temperature. So temperature is one of our most common measurements that we do in chemistry and biology, physics, you name it. In almost every profession, we are always surrounded by temperature. One of the things you might look at before you go outside is it hot? Is it cold out? Do I need a jacket? Should I wear shorts? Are you trying to figure out exactly what it is that to prepare yourself for the elements? So when it comes to temperature, we can measure it in three different scales, depending on usually where you live and really what you do for a profession. Now, when it comes to these, so thinking of them, so either talking of if something is really hot or if it's really cold, how do we look at it around the world? Well, being that I am in the US, the most common way we usually look at temperature is with the Fahrenheit system. However, the entire world, for the most part, uses Celsius. So one of the things I preach to all my students is that we need to learn the Celsius system because we are a global scientific community. We need to be able to talk about science in the same language so that way we can understand what everybody is working on. And it's a system that generally works very, very well mathematically when it comes to deriving a lot of our calculations. Now, Celsius is not the only system that we'll have. We also have Kelvin, which is our SI unit for temperature, believe it or not. Celsius is a SI derived unit off of Kelvin. So this is the metric equivalent. So it's used generally in the metric system. Now, what do you usually need to know? Well, just kind of know the general difference. Kelvin is known as an absolute temperature system. So it works very, very well when we're trying to describe the physics behind how different atoms and particles and molecules behave. So absolute means that it can only be a positive value. There are no negatives. So if you notice at the very, very bottom, what is referred to as absolute zero. So the coldest temperature theoretically possible is around 0 Kelvin. And scientists have been trying to get as close to measuring absolute zero as possible. Last time I checked, I think they've got down to nano Kelvin or pico Kelvin, so 10 to the minus 9 Kelvin, so very, very close to absolute zero. When that happens in physics, it's usually when molecules and atoms, they don't move anymore. They stop vibrating and actually moving and doing what they usually do, right? They are no longer getting excited. So what do we exactly have to think of in terms of temperature scales as chemists is we like to relate things towards water, right? Water is what is about life. So when it comes to the freezing point and the boiling point of water, I would highly recommend you know them for any career path you have because it is common knowledge, especially when it comes to Celsius and Fahrenheit. Celsius, the freezing point is 0 degrees, and the boiling point is 100 degrees C. So there's a difference of 100. It's very easy to remember. Versus Fahrenheit, 32 degrees Fahrenheit for freezing and 212 degrees Fahrenheit for boiling. We also have our common body temperature, which is around 37 degrees C, and room temperature is around 25 degrees C. So what is temperature all about? So the definition, just to put it out there so you have it, is that it's the measure of how hot or cold something is, right? So if you go outside, you can tell how cold or hot it is. Now, what exactly does this mean? Well, it reflects the average kinetic energy of atoms and molecules. I mentioned that it had to do with how much they're vibrating and moving around. Molecules are moving. Even the solids in your laptop and things that are just sitting around you right now, they are vibrating. So they're moving back and forth. They're oscillating the atoms. It might be really slow or you might not really notice it, right? Unless you have an atomic microscope, right? Which we can't see that far down with normal conventions, is that they are vibrating all the time. So when things get excited by heat, they start moving more and more and more, and they go a little bit faster and faster and faster. Versus when they're cold, they move slower. Things don't go as fast. So now keep in mind, temperature and heat are not the same thing. Temperature is all about the average, is a relationship to the average kinetic energy, whereas heat is all about the flow of energy. So if you think of if you put like a pot on the stove, you turn on the fire, and then the fire's heat goes into the pan, right? That's a flow. So that's heat. It's all about energy, and we'll talk about that in later lectures. Temperature is just hot or cold, right? So just a raw value. Let's take a look at the different units that you will see. So going off of Kelvin, Celsius, Fahrenheit, let's see how we can calculate them. So the first unit is looking at the SI unit of temperature, which is Kelvin. But this is something that is used in the scientific community, but most of the world, it likes to use Celsius, which, like I said, is an SI derived unit because we can solve it using a formula. So how would we do that? Well, in order for us to go between Kelvin and Celsius, it's really straightforward. Kelvin is equal to Celsius plus 273.15. Or if you wanted to solve for Celsius, it's Kelvin minus 273.15. We're just adding and subtracting. Now keep in mind, there are some little differences between the notation here. If you notice next to Celsius, there's a little circle next to each of them. This is a degree symbol. Kelvin does not have a degree symbol, meaning that it is that absolute scale. It is how we measure things without having to worry about negative values. So it does not have that degree value. So let's try to practice a problem to solve for Celsius or Kelvin. Let's take a look. Helium, which exists as a gas at room temperatures, can become a liquid. So think about all the helium that you have in balloons at birthday parties that floats. It can become a liquid. But that happens at 4 Kelvin. At what temperature is that in Celsius? So what were we given in this problem? So the first thing what we're going to do is we want to kind of highlight and underline or write down all of the givens in the problem. So we have 4 Kelvin, which is given, and we want to convert that to Celsius. So what can we do to do that? We are going to use Kelvin minus 273.15, which was equal to Celsius. We're going to use our formula from earlier. So let's write that down. So Kelvin minus 273.15. So let's see what our answer is. So our Kelvin value is 4 Kelvin minus 273.15. And what we are going to get as a final answer is negative 269.15 degrees C. Being that we only have one sig fig though in this problem, it's kind of really bad of me in terms of the sig figs, but usually when we're going through this, we are just subtracting, so keep that in mind. We have to just either remove or take away decimals. So we would round this to 260 degrees C, being that 4 Kelvin did not have any sig figs. So that would be our answer. So we always want to put it in the correct notation. Okay, so that's very, very cold. Keep in mind 0 degrees is freezing. So this is negative 269 degrees C. It's almost absolute zero. Your human body would instantly freeze if you were to come in contact with this. And would not last very long. Let's take a look at the next set of units, which is Fahrenheit to Celsius. In the USA, we use Fahrenheit in our country, which, unlike the rest of the world, which uses Celsius, we are pretty stubborn and stuck to it. So we have to be willing to know how to convert to Celsius in order to speak to the rest of the international community. It's a pretty straightforward formula to do that. Both of them are usually always given as references on exams and quizzes in most courses, but sometimes you might need to memorize them depending on who your teacher is and who you are taking a course with. But generally, it's always available to you. You can look up the formula at any point in time. I know my courses, it's always given to you. So let's say if we have Fahrenheit. So the way that we would use this formula is we would take the Celsius value, times it by a fraction of 9/5, solve for that, and then add 32. Or we could take Fahrenheit minus 32 times 5/9. Notice how the fraction flipped between the two, and that would give us our Celsius. Now, If you don't like fractions, let's say if fractions are a little too scary and a little too spooky for you, right? Fractions can be a little scary. There's an alternative version of this, which is actually a lot easier to kind of see here. So Fahrenheit is 1.8 times Celsius plus 32, or Fahrenheit minus 32 divided by 1.8 is equal to Celsius. So a lot easier of a formulas to use. You can use either one, whichever one you prefer for your courses. Usually I usually use this one more often on the bottom here, but I do know some people prefer the traditional fractions. Let's try a practice problem to use this. Compost can be made at home from grass clippings, kitchen scraps, and dry leaves. As microbes break down organic matter, heat is generated. The compost can reach temperatures of 155 degrees Fahrenheit. Keep in mind your body temperature was 98.6 degrees Fahrenheit. This is very, very hot, which kills pathogens, meaning anything that's harmful. What is the temperature in Celsius and Kelvin? Okay, so first thing you want to do is there's a lot of info here. So we want to highlight and find anything that's really important. So we have 155 degrees Fahrenheit. And we want to convert to Celsius and to Kelvin. So, all right, first things first, 155 degrees Fahrenheit. The only formula that we have is converting that to Celsius, which is what we had earlier, right? So which one would we want to use here? Let's use the alternate version. So being that we want to convert to Celsius, we would plug in our 155 minus 32 in this format here. So let's use it. So if I had my Celsius, right, we had 155 degrees Fahrenheit. We'll minus that by 32, and then we'll divide that by 1.8. And what we are going to get is 68.3 degrees C as our answer, which is very, very warm. Now, the other part of the problem was for us to convert this to Kelvin. So how exactly would we go about converting Celsius to Kelvin? Is we would do our 68.3 degrees C, add to 73.15, and this would convert us to Kelvin. Okay, so Kelvin is going to be equal to that, which what we will get for our final answer is 341.5 Kelvin as our final answers. Okay, so that would be both of them here as our answers, and that is how you can solve from Celsius to Fahrenheit, or using Fahrenheit to get to Celsius and Kelvin. Keep in mind when you're working in the lab, you will always be using Celsius, except for when you're working generally with gas laws or different things that require the absolute scale. But Celsius is commonplace generally in every chemical lab in the US and in the world. Is you have Celsius thermometers, and even more in healthcare facilities, it's more common for Celsius to be used as well now, even in the US. So in all professions, we are trying to start to slowly use Celsius more and more, being that we are an international community. All right, this has been all I have for temperature. I hope this video helps you for preparing yourself for future labs, and I will see you all later. Thank you so much for listening. Bye.